Hello, everybody. Thank you for coming to eighth grade science. This is your lesson for today. Um, Again, as I mentioned in Google Classroom, I will not be online. However, if you need help in anything, send me an email and I will try my best to get it to you. All right, so I wanted to include a little, let me move myself out the way. Oops. Okay, so I wanted to include an example of your notes. Again, that is very, very important. You can pause this right now, take a read of what's supposed to happen in your notes here, and look at my example. Okay. All right, welcome back. Today, you will be able to divine the last three steps of the scientific method, and you'll be able to use the scientific method to create an experiment in your daily life. Um, well, we will also list the three major components of a well-written specific scientific procedure, and we will also practice giving specific, concise, and scientific instructions. Okay, um, by completing a STEM challenge activity and picture activity. That goes along with our egg drop challenge, and that'll be more to come. Okay. All right, the scientific method, the last three steps. So let's review really fit first. We know that the first step is to identify and state the question or problem. We must make sure that our state or question is testable, okay? It cannot be vague and must be answerable. All right. In this case, we have which airplane will fly the furthest. If we had airplane A and airplane B, which one would fly the furthest and why? After we get our testable question, we must do background research. In this case, we have some background research on airplanes as according to our scientific question. You do not want research that has nothing to do with your question. Your research should be solely based off of your scientific question. And the scientific method 3, state the hypothesis. We went over that. We drilled it. We know what we can identify the IV. We can identify the DV. We know what a control variable is. And we know how to write a hypothesis, okay, in the if-then format, just like this. So if airplane A was made with triangular wings, then it would fly further because airplane B does not have, because airplane B wings are circle. Okay. Um, so based off of our research, we do our hypothesis. Now, the next three steps in our scientific method is write a procedure. We're going to spend most of the time on talking about how to write a procedure. A procedure is designing and forming an experiment to test the hypothesis. We also know that procedures are steps in numerical order, like step 1, step 2, step 3, step 4, step 5. We write those steps in numerical order so that if anyone comes back, they will be able to retest your hypothesis as needed according to the steps that you followed. Procedures must be clear and exact instructions that, if followed, would replicate or copy your experiment to a T, okay? You can either use step 1, step 2, step 3, or you could use first I did, then I did, next I did, and finally this happened. What are good procedures? Good procedures are 1, step by step, okay? Step by step. Day by, okay, that's old. It's telling my age. All right. So first is step by step. Good procedures are also specific. That means deets, deets, deets. We need all the deets. If you look at put the peanut butter and jelly on the bread and eat it, that's not good deets. That's not telling us anything. Let me see if I can get my wine. Yeah, that's not telling us anything. But this step 1, gather materials. Here are my materials. Step 2, lay bread on the plate. Here's the bread on one side, one side beside one beside the other, and so forth and so on. Okay, this right here, well detailed. It has all the D's. When you have all the details that you need, there is no room to second guess or to make up your own ideas of what the scientist was trying to portray, okay? Also, good procedures are written so that anyone, anywhere can read and do them. That means they start or use verbs and not pronouns, okay? Oh, two of my things are not showing up. All right, so here's the most important part before as we continue. You can pause here, write down your notes here. All right, thank you for coming back. So I'm going to briefly talk about what you just wrote down. You just wrote down the characteristics of good procedures. These four basic characteristics are very, very important. Procedures must be scientific, meaning using science words. Okay, now I took a big spoon and scooped up some peanut butter. I have a tablespoon full of peanut butter with a teaspoon of jelly. So you have to use measurements, use scientific instruments, things of that nature. It must be sequential, which means going in the exact order. It must be detailed, okay, that anyone, anywhere can replay or reproduce your experiment. And it must be precise and clear to the T. No room for error, no room for imagination. Exactly what's in your procedures is the exact steps that I need to take to recreate your experiment. All right, so I want you to take the time out to read these two scenarios. Once you finish reading these two scenarios, as you can see, scenario 1 is not good procedures. Scenario 2 is a good procedure, as an example of a good procedure. Same here. Step 1 is an example of a good procedure because it's in sequential order, 5, 6, 7, and it also uses very much detail. Plant 1 in the sunlight for 2 hours, put plant 2 in the sunlight for 4 hours, and so forth. Move the plants away from the sunlight after a certain amount of time. No details whatsoever. That gives me room to imagine what the scientist was trying to get me to do. Same here. Number 1 is a bad procedure. Number 2 is a good procedure. Why? Because you have the correct measurements, you're very concise and clear, you're straight to the point, you're in detail. It's still in sequential order, just like number 1. However, it's very specific, and that's what makes it different from number 1. Okay? So you have to be very careful. All right, so now, since we are collecting, after we write our procedure, we must collect and record data. Um, the following procedures with your test objects will give you data or information to use to make a conclusion based on your hypothesis. Okay, let me move my picture out of the way. You must perform the procedures to write down detailed information you find when you have various data findings. Your conclusion to the hypothesis can develop accurately. Okay, so you need you need so much data. It should be able to fine tooth comb your experiment to help you come up with a clear conclusion to see whether your hypothesis is correct or not. Okay, you must do that when you're recording and collecting your data. Okay. So I will post this video in Google Classroom for you to watch to talk about the experimental process. Actually, no, I won't. I will stop here. This is part A. Go ahead and close out this part and go on to your second part of your lesson. I will see you in a few moments.